The population of microbacteria starts at 1 gram and triples every day. So I see the word starts at 1 gram and triples every day. So that seems to be the key information that we're going to need. So we want to make a table and sketch a graph to model this situation. Already it is seeming to me that it will not be linear like our previous examples because tripling is a multiplier. Tripling means times 3. So let's see what that would mean for our table. So D equals number of days and Y equals number of microbacteria. You could call this D or we could call it X. This is your independent variable, which is going to be here. If we're going to say that that's D, you could label your axis as D, and then Y is our number of microbacteria. So looking at our table at day 0 which would be the start, we know that there is just 1 gram of microbacteria. And then after that, it triples each day. So if it's tripling, that means we're going to take that value and multiply it by 3. 1 times 3 is 3. And each day it's tripling, so 3 times 3 is 9. And we're going to continue this pattern all the way down our table. So we have a common multiplier. So feel free to use a calculator or a multiplication table as you're doing this. 9 times 3 is 27. You can see how quickly we're increasing. 27 times 3 is 81. And 81 times 3 is 243. So hopefully we're recognizing here, because we have a common multiplier, that this is an exponential function. And you can see that with how quickly our y values are increasing. We have an increase of, by 2 here, by 6. Now we're increasing by almost 200. To choose a scale here, I'm simply going to go by 1 for my days. And to go for the monobacteria, I know that already at day 5, I'm at almost 250. So if I go by 100, 200, 300, I'm already to here. It does give me a little bit more. So I think these big marks here, I'm going to go by 100. And to plot my points, so that means every box vertically is 50. And that means for a while, these are going to be pretty small. So at the start at 0, I'm at 1 gram. Basically, that's going to be on the line. At 1 day, I'm at 3 grams, which is still basically on the line because this whole space is 50. At 2 days, I'm at 9 grams, which is still pretty low. I mean, you can see it's a little bit increasing. And at 3 days, I'm at 27. So if this whole thing is 50, 25 is about halfway. So it's just a smidge over that. At 4 days, I'm at 81. So 75 would be halfway between here. So a little bit above that. And at day 5, I'm at 243, which is about 250, a little under. So 250 would be right here. So it would be just a little under. And so you can see we're getting that lazy L shape that we've come to expect for exponential functions. So we can write down what type of function this is and how do we know. We've been talking about from the multiplier here or the shape of our graph here. So we really want to know, how do you know? When you're looking at this, did you know right away when you read the description of the problem that triples was a multiplier? Did you see it once you did the table? Or did you recognize it once you sketched the graph? For me, when I see a multiplier, I'm thinking exponential. You might have a different reason when you're thinking about this. What does the x variable stand for in the problem? It represents the number of days. That's our independent variable right there. What does the y variable stand for? The y value represents the amount of bacteria. And again, you see that that is written in the second column, which is associated with our dependent or y variable. And this was measured in grams. What is the multiplier, the b value? Value is 3, and you can see that in our table. That's what our multiplier is, times 3. Tripling means times 3. That's where you're going to see that in the information we're given. What is the starting point for this function? This is going to be your y-intercept. At day 0, the amount or number of bacteria is what? So it is 1. You can see that from the table, and up here it says it starts at 1 gram. If you know the y-intercept, then you know where the floor is. When we were graphing from an equation in the last unit, we knew the floor first, and we knew that the y-intercept was 1 above. If the y-intercept is 1 above the floor, then the floor needs to be 1 below the y-intercept. And if my y-intercept is happening at 1, then 1 below that is going to be 0. So the floor is going to be at 0, or you might say y is equal to 0 for that horizontal line. Or you could even say the x-axis. You can see that this is where our floor is right along the x-axis or the y equals 0 line. So write an equation to represent this situation. So we just said that it is exponential. Our general form for exponential is y equals b to the x plus k. And we know that the k value is associated with the floor. And up here we have the b value, which is our multiplier. So we're ready to plug that in. Y is equal to our b value, or multiplier, 3 raised to the x power, plus the k value, which we said that our k value is 0. So you could write that as y equals 3 to the x plus 0. That is exactly the same thing as just saying y equals 3 to the x. You don't have to have the plus 0 because anything plus 0 is the same thing. How much bacteria will there be after 5 days? See the table. So let's look above at the table. After 5 days, we should have 243 bacteria. And that was measured in grams. Let's test this in our table. In our equation. So we know that it should be y equals 3 to the x. And this is our x value. 5 is our x value. So y equals 3 to the 5th power. And we can use our calculator to do that. Let's talk about how we'll do that. So clear that. 3, and if we're trying to raise something to the 5th power, we want to use this little arrow key right there, that little caret key, and put in then the exponent, which in this case x is 5, so we're going to put 5 in there. And you can see that we do get 243.